Okay, so most of you finished this today in class today, so let's just kind of check it and see how you did. First one, all three of these are arithmetic patterns. That's what we're reviewing first. None of these are geometric, so let's see if we can figure this out. Notice if I'm not sure what these are adding by, sometimes we get confused when the numbers get bigger, please grab a calculator and do 19 minus 13, 25 minus 19, 31 minus 25, and you'll notice that this is adding 6 repeatedly. Did you get that? So then I go 31 plus 6, you got it, 37, and then 37 plus 6, you got it. Should have been those two numbers. Now the recursive, when it's not specified, all patterns are assumed time 1 unless otherwise told. That means I could like make a little table here with a 1, 2, 3, 4, but it's a time 1. Why is that important? Because in my recursive here, I'm going to begin with f of 1 equals 13, f of n equals f of n minus 1, and then the pattern of adding 6 each time. So notice where all these parts come from. I see that the time 1, the assumed time 1 goes here. I see that the 13, this first output, goes here, and I see that this adding 6 repeatedly comes from here from my work. All right, pause the video, try the next ones if you haven't yet. Let's go over the explicit. All right, let's see how you did. So here our explicit uses those same three numbers. It's a function, or it's a sequence that begins at 13 and is adding 6 repeatedly to the previous term beginning at time 1. So notice it's a big n minus 1. Later we're going to have a small exponent for the geometrics, but right now it should be big. Notice those same things and where they come from, that this plus 6 shows up here. Notice that the 1 shows up back there, time 1. And notice that the output 13 is where I'm beginning my function at. Notice where those appear in both types of functions. Great job. Let's see how you did on the next one. If we're not sure what this one is going down by, grab a calculator. 38 minus 43. 33 minus 38. 28 minus 33. I hope you got that this was minusing 5. So 28 minus 5, did you get 23? 23 minus 5, did you get 18? Assumed time 1, f of 1 equals 43. F of n equals f of n minus 1. Say these out loud as you are doing these at home. Minusing 5 each time. F of n equals begins at 43, subtracting 5 every time to the previous term minus time 1. Last but not least, this one has a fraction. It makes us feel weird, but just look at these positives to start. To go from 0 to a half, we're just adding a half. Then look back at the negatives and see if it makes sense. So a half plus a half is just 1. 1 plus a half is just 3 halves. That's it. Recursive goes like this. F of 1 equals negative 1. F of n equals f of n minus 1 plus 1 half. I had students in class ask if it was okay to do plus 0.5. Of course. And then the explicit begins at negative 1, adding half every time to the previous term. How'd you do? All right, graphing a linear equation on this next one in the mx plus b format means that they want you to identify that beginning point of 9. So go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and put a dot. I'm going to label that 5. I'm going to label that 10. Sorry, these aren't dark enough. Let's do a different color. Hang on. All right, my graph is now labeled and scaled. So begin at 9, there's my B, and then count this slope, negative 2/3 going down from there. So what kind of work do I look for on these? I look for you to write that my M is negative 2/3 as down to right 3, and my B is 9, or 0,9 is my y-intercept. Either way, that's the kind of work I'm looking for. So going to the starting point of 9 and going down 2, right 3, put a dot, down 2, right 3. And then I can also go up 2 and back 3, depending on how much space you left for yourself and how you scaled it. So then I connect the dots. This is going to be a common question in this first week of when do I connect and when do I not connect? And we connect on all functions given in just this little format. All functions are continuous. Are continuous when there's no context otherwise, and that means that the graph is connected. So for these two graphs, you are going to connect the line. Okay, last but not least, we have an equation. Instead of being in slope-intercept form, that's this guy up here. Let me go write this. Slope-intercept form is known as mx plus b. This is given in point slope form that goes like this. Y equals m x minus x1 plus y1. So what's staring at me this time? It's not a y-intercept, it's an x1, y1. So my x1, y1 of this equation is just a beginning dot, not at an intercept, but at the coordinates 4, 1. So I go 1, 2, 3, 4. Here's my 5 marker. And then I'm going to go graph it. I'm going to go right 4 and up 1 and put a dot. And that's my beginning dot at x1, y1. Now from there, I'm supposed to count a slope of 2. Do you see where I got that from? This letter, this number, I'm sorry, right here. So how do I count a slope of 2? It's up 2 over 1, up 2 over 1, up 2 over 1. Or down 2, back 1, down 2, back 1. But bottom line is, this better be a positive sloping line or I've done something wrong. There she is in all her glory. There it is. All right, how'd you do on this page? Hopefully well.